fetch.ai, a futuristic artificial intelligence project being developed by professors at some of the best universities in the UK. Essentially, they want to give you your own AI assistant which can control and monetize your data, among many other things as well. This project is truly mind-blowing in terms of its concept, so even if you're not looking at investing into projects at this time, if you simply like to imagine the future and how artificial intelligence could impact our lives, this could be a very interesting interview for you. Hi, I'm Tom from Crypto Gurus, and if you want to learn more, keep watching. First up, the disclaimer. Nothing in this video is financial advice. Please pause the video now and read the disclaimer in full. At this point, some of you may be thinking, well, it is interesting to hear about upcoming projects, but I also want to hear your take on the overall market. Have we reached the bottom, and when will Bitcoin rebound? I want to let all of you know I'll be releasing a video tomorrow on that topic. I don't just want to kind of speculate on it. I like to do a bit more background research, so I'm still compiling that at this moment. Instead, in today's video, we're going to be talking about Fetch. Why should you be paying attention to this project? Number one, they have a very strong team. Number two, the concept is pretty mind-blowing. And number three, in spite of that and the fact it sounds very futuristic, they actually already have a private testnet up and running. So this isn't just theoretical, this has applications which can be applied very shortly. With all of that said, would I invest into the project? I've been very straightforward and honest with all of you for a long time in saying that I don't think the ICO market is very attractive. I've been saying the same thing for the past 6 months, which is why every single opportunity that comes my way, I say no to. There may be some rare exceptions out there. I personally haven't seen them. So overall, the prevailing market conditions have led me to the same decision I've made in the past. So why am I making this video then? There are 2 reasons. Number one, my income simply relies on it. Without these videos, I wouldn't earn a living and I'd have to go get a normal job. I wouldn't be able to continue making these videos for you. And number 2, I believe that the market is going to turn around, which will trigger the ICO market to return, even if there is a delay. As a result of that, I want to be aware of the upcoming projects which look very interesting. The last thing I want to do is find that the ICO market has returned and I haven't prepared beforehand. So I'm still looking at upcoming projects, not necessarily for now, but in preparation for when I believe the market is going to turn around. Why should you watch this video? What are you going to get out of seeing this? Well, there are 2 reasons here again. The first one is simply that it helps me. As I say, these videos literally fund the channel, so if I wasn't getting views, I wouldn't be able to continue the channel. So simply by watching this video, you're helping me to continue making content. So thank you very much for that, I have to say. And number 2, if you're the type of person that simply likes to imagine the future and some of the crazy applications that AI could have in our lives and how it could change our daily lives, this really is the perfect interview for you. You're going to find this very fascinating. So with all of that said, let's begin the interview. I'm here today with Toby, the CTO of Fetch. Thanks so much for joining me.
It's a great pleasure, thank you very much.
Do you want to just briefly break down what Fetch is in like the 30-second elevator pitch?
In 30 seconds, right, I know. Fetch is about rolling a red carpet out in front of everybody. It's about making today's extremely complicated lives much, much easier by getting all the individual moving parts in the economy, and for that matter, all of the problems that we encounter, get them to look after themselves. So bring the machines, the digital parts of life to life, and give them the ability to solve problems on your behalf and present solutions directly to you.
Okay, fantastic summary. We'll jump more into that in a minute, but first, do you want to run through your background, kind of explain what you've done in the past and what makes you qualified for this project?
Sure, okay, well I come from a computer games background. Started in the early 90s developing computer games and learned very quickly that developing stuff from the top down by writing code to solve a problem ends up with an awfully large amount of code and you end up drowning in complexity. I rapidly learned that in fact metaphors from biology are really, really good at dealing with this complexity. You know, nature does this stuff very well. When you look at a beautiful plant or any animal or the things that bees and ants and all these stuff that they build, there are lots of small individual components, but together they do something grand and amazing. And that ability to get emergent complexity out of a large population of simple parts was very exciting to me, because I didn't need to know how to solve the problem in order to solve it. Curious as to whether or not that worked in virtual worlds, which of course it does. You can build very, very large virtual worlds that way and make everything in it real. And then around sort of mid-2000, myself and one of the other co-founders of Fetch, we were talking about whether or not that could be extended to the economy. That if we brought everything around us, pieces of hardware, services, infrastructure, data, if we could bring those things to life and put them in a world, we'd have something really interesting. But in the end, it was scalability that kicked us around a bit, along with being able to do microtransactions and a few other things. And then there's a gap before along comes decentralized ledger technology and blockchain, and we suddenly thought, ooh, this is interesting. This allows us to manage this scalability, because now we can solve all of the problems we had. We can create a world any size we wanted to, because we don't have to trust any individual computer to be able to use it. We've got the computing power we need to be able to adapt this world in real time to suit the inhabitants of it. And we've got the method of providing value exchange between all of these individual component parts. And that was effectively the journey that led us to thinking that, well, actually now Fetch can be done.
Okay, so that kind of encompasses the virtual world, as you say, and the autonomous economic agents that are within the project. It's quite a confusing topic, so I think the easiest thing to do to break it down for the audience is to compare it to similar projects, in the sense of there are many projects which are focusing on freeing up data with the blockchain, allowing people to take control of their data and sell it. Fetch is along the same lines, but very much different in many ways. Do you want to offer a comparison between that type of project and Fetch?
Yeah, okay, so Fetch we didn't start out looking at blockchain thinking this is a cool technology, we can build stuff out of it. We started out with a problem that we've had for very many years, thinking, okay, this allows us potentially to solve this problem that we haven't been able to solve before. And it's about bringing these parts to life. It's the machine-to-machine economy. We often describe Fetch as an economic internet. We're creating a place where all these individual machines can effectively do business together. And that's very different to a lot of the other projects out there. In fact, we think that that approach to bringing all these things to life and giving them a world that adapts to them is unique. And it's a convergence of very interesting technologies, because none of this stuff exists in isolation. I mean, blockchain isn't an isolated technology, it's an enabling technology. You combine it with other stuff like artificial intelligence and machine learning and multi-agent systems and virtual worlds and some of the very other exciting things that are going on, and you can get something really cool that's a lot more than the sum of its parts. It's about creating new kinds of platforms where new things can occur. And one of the things that Fetch does is it potentially changes the role of intermediaries in the economy. Because you've got self-service trust, and because you've got digital representatives of you, your information, and all the other individual parts that you need, they're able to work together to solve problems, which means you've got all these things that are out there solving problems for you without you having to make the effort. And I sort of feel that with all this incredible technology that we have, it still seems a bit strange that you and I as individuals have to do most of the work. The idea that representatives that know us could do that work for us is really exciting.
And those representatives are the autonomous economic agents.
Yes, they are.
So they're kind of like, how would you describe them? They live within the virtual world.
So I would call them digital representatives or digital entities. They can represent data, hardware, infrastructure, services, you. And they exist in a world that is constantly changing itself in real time to present each inhabitant with the optimal view for it, which is why I often describe Fetch as the ultimate dating agency for value providers. It's about reducing the distance between something that has something and something that wants it, or much more interestingly, something that might want it. And it's that speculative introductions that is possible with something like Fetch that's really interesting. Because as an individual, if you've got a piece of data and you want to sell it, then how are you supposed to think of all the possible applications that data might have? Whereas, of course, if you've got a system that's restructuring itself to present all the possible uses of that data directly to you, then all those opportunities are there. So that increases utilization enormously, but also introduces all the potential applications of being able to connect all this stuff together.
Okay, so that's a nice breakdown explanation. I I think the easiest thing to do now would be to run through some examples. How would that apply in the real world?
Okay, there's a bunch of examples. Example number one, why shouldn't you boil your kettle off the power in your neighbour's car? If you have autonomous economic agents that represent all the power storage devices, all the power generating devices, and all the things that might use it, they can negotiate with each other in order to be most effective. Now, right now, we have all sorts of strange things like feed-in tariffs and all that stuff. That doesn't work very well. If you could manage this on a more local level, and you could have digital entities whose job it is to increase their utilization or get the best value, negotiating with each other in order to do this, then you've got something very interesting indeed. Because you don't care when your electric car charges, so long as it's charged enough for you to get to work in the morning. The fact that it did it in half-hour chunks here and there and everywhere throughout the night is of no consequence. Or if you're not using it because it's a lazy Sunday, why do you care if you're in fact selling the power that's stored in that to somebody else in order to do something else? Now, that idea where you've got lots of solar panels on roofs and windmills here and there and sticking in people's gardens, that none of that power goes to waste because it is effectively, you might be charging somebody else's car down the street as opposed to just excess production because you're on holiday and it's not going anywhere, is really interesting. Because when you break it down into those individual decentralized parts, you have something that's far more robust. And then there's the issue of that things know what they are, right? But they're not able to do anything about it. One of the discussions we've been having recently is with infrastructure projects where you've got lots of equipment lying around, and that equipment might not be used effectively, or it might have been left parked in the wrong place and it isn't where it should be. But how are you supposed to find that? And how are you supposed to know where it is? Well, it knows where it is, so why shouldn't it say so? Why shouldn't it tell the people that matter that I'm sitting here and not doing anything? The idea that you're devolving that authority to solve a problem to the actual parts is incredibly valuable when it comes to things like infrastructure projects or equipment anywhere, or just making good use out of the stuff that we have.
Okay, this all sounds like quite a dystopian future in a way. How like practical is it? So, for example, connecting a car to a boiler, what steps would have to happen? Would you have to have, I presume you have to have a smart boiler with a smart car, and you would have to install some sort of software? What would be the steps you'd have to
and certainly for some of these things there are quite a few hoops left to jump through. But there are some very interesting projects taking place all around the world where when they're building these new places where they're looking at putting a much finer grain of control on how all of this power distribution stuff works, precisely to enable this kind of decentralized kind of application. The idea that you actually bring those parts to life to make them responsible for their own lives, digital lives, is where we are different with what we're doing with Fetch. Because you get those intersections between markets that you hadn't really imagined. And one of the really interesting technologies that we're using is creating a semantic view of the world. The idea that you might be able to stand at healthcare and look towards transportation and see what markets that intersects. Now that's a very powerful alternative view of the world. And if you're an agent and you're trying to find the best place to deliver what you have, that's a wonderful view to be able to have. Not just to be able to look geographically or economically, but to be able to look semantically by content.
Okay, it's quite mind-blowing, to be honest with you. It's very complex.
Yes.
And down the road in a certain way, if you know what I mean, because there are certain hurdles you have to overcome, but the economic sense is obvious.
Yes, but not with everything. There are a number of applications where this can apply right now.
Okay.
Well, data utilization is one of them. I mean, you walk around with a smartphone that's absolutely jam-packed, full of really interesting sensors. Where does that value go right now? Does it go to you?
No.
Okay. You're driving along a car. There's all sorts of sensors in that. Where does that value go right now? Does it go to you? Sometimes, the best possible case, it's packaged up by a third party and sold on your behalf. But it's not your data, even though it should be. But the fact that a whole bunch of people stick their phones in their pockets on a London street probably means it's just started raining. Now that's useful information if I'm trying to decide whether to get in a tube or walk to the station.
Absolutely. So this actually brings up one of... Sorry.
No, go ahead.
No, you carry on. I think you answered something
else. All of these individual sensors combined and transformed in other ways are agents in their own right. Weather sensors and other bits and pieces that you have in your house, those are agents in their own right. Whereas previously you'd get very little value out of those component parts, well now you can get value out of them. And Fetch provides the infrastructure to allow that to work, but the infrastructure to discover new opportunities for these data and services that weren't otherwise obvious.
Okay, so one of the points you mentioned there is kind of similar but different to other projects in this space related to the data. So like there's many projects in the blockchain space which are currently trying to put data back in the hands of users so they can choose to monetize it. One of the key aspects of your project is that you won't actually make the decision yourself, or you could make the decision, but you won't have to, because you have an autonomous economic agent which is doing what is best for you. So that data can be sold, which overcomes one of the key issues which currently exists in data. That is, much data is out there, but it's too expensive to sell and acquire, so it's not correctly used.
And that's a very, very key point.
Yes.
And it's not the data that we use that's interesting, it's the data that we don't use. And either because we don't know it's there, or because it's too much hassle to incorporate it, or because the cost to deploy it exceeds its value. And that reminds me of a story I was told a year ago now, from Big Data Warehouse, that he said, our problem is the data doesn't get up on its own 2 feet and sell itself. And he said, if I want to sell data, I have to get on an aeroplane, I have to sit in a room. This takes months. We end up with paperwork up to here, lawyers everywhere, and this is complicated stuff. He said, if that data isn't worth a fortune, I'm not even going to move. So you think how much is wasted. Now with something like Fetch, well, no, not a problem anymore, right? Because you can trivially attach endless numbers of autonomous economic agents to represent that data and dump them onto a world that's going to restructure itself in real time to best place that data. The worst scenario is that the agent doesn't get any luck. Which is a lot better than you've spent goodness knows how much money trying to deliver that data to someone who you discover it doesn't.
The first thought that came to my mind when reading this, and I'm sure I don't have the technical knowledge to really understand the difference between these two things, the first thought I had was, what's the difference between this and something, the type of project where you could automatically sell your data, because you might make a decision, so you might have an application, you say, oh, I'm willing to sell this data, and then that automatically goes through and a smart contract continuously carries that out. So I'm thinking with the autonomous economic agent, it might sell the data for you, but you want to control what data is sold. So you at some point will have to begin the process.
You're always in control because it's your data.
How is that different to a smart contract? Right?
Okay, smart contracts are involved. We've had to create our own unique smart contract system because we needed to be able to do quite extensive computing on the ledger. As cool as smart contracts are, you couldn't implement a neural network in them. I mean, the gas costs alone in Ethereum would make you bring tears to your eyes in a very short period of time. But it wasn't designed to do that. So what do you expect? But we wanted to be able to do very large amounts of computing for all sorts of reasons. And one of those is to generate information for the users of the network, but also to allow far more complicated AI and machine learning things to exist on the ledger itself, which has a lot of applications. But one of the reasons that this differs from all of those is that it's the machines, it's the digital entities that are doing the stuff. So it may well be that by the time you come to be given a piece of information or a solution to a problem, many, many, many layers of autonomous economic agents have been transacting between each other. So one example is you might have an agent that represents a railway station, and that is buying up very cheap, low-value information from people walking around off their phone sensor devices to get some picture as to what's going on. And it's then transforming that with some AI to generate some interesting predictions, so that it's able to tell you what the scores and the doors are at the station and make predictions as to what platform your train's going to turn up at that you wouldn't otherwise have. And each layer of these agents that's doing this is talking to each other in a machine-to-machine way, and no humans are involved. It may well be that other agents are buying up from all the stations in order to build this map of what's going on in an entire area, and so on and so on and so on. By the time you pick something up for 10 cents, just to get the information you want, goodness knows how many layers it's been through. So it's enabling those machines to be able to get on and do this work that is one of the things that's particularly unique to Fetch. So it's not just a peer-to-peer network where you've got all the individual computers on the network, but connected to each one of these computers are all of these agents. And they're able to move around this space, they're able to find other agents as delivered to them by the Fetch network. And all of that collective knowledge that's built up about how markets intersect, when they intersect, under what conditions they intersect, is built up for the benefit of all of the users of the network. So it's not just locked up in individual centralized silos. It's there, as we put it, as a collective intelligence for the benefit of all the individual intelligences that are attached to it. There may be tens of billions of these agents working together in order to be able to deliver these solutions to individuals.
Okay, so a lot of this sounds groundbreaking, absolutely. Like, you can imagine it happening in the future, and it's better than, it's quite frankly sounds better than you choosing to sell your own data. It's effectively something working for you, which something with artificial intelligence is a big step forward. But it also sounds like it would be almost further down the line of some of these projects, which kind of brings up the question: where are you in terms of your roadmap? What do you want to explain to the audience where you come, like, what have you achieved to this point, and what's going to be seen in the future?
Well, the good news is it works.
So you have a test net up and running?
Yeah.
Okay.
We've got a private test net that's up and running.
Okay.
We've ran that up to over 250 individual nodes on that network. We're actually building applications with people.
What kind of things have you tested?
Oh, all sorts. But one of the things that's quite interesting, we've even discovered at this stage new applications of fetch that we hadn't really originally considered. One of them, for example, is user interface optimization. Now, one of the problems you get when, say, you walk into a hotel and you install their app and you're sitting there in the bar ordering a drink, is that you probably have to go through 5 layers of menus before you find the thing that you wanted. Now, one of the things that's missing from that is context. And another one, and context comes from many, many things. It comes from where you are, who you're with, your personal preferences, all sorts of stuff, right? Now, you may not be happy about providing all of that information, and if you had to feed all that information into an app every time you walked into the bar, you wouldn't get very far. And that's a problem, because every user interface, every click you go through, you lose people. And the idea that something like Fetch, if you could treat all these individual component parts, all the things that you might be able to buy in the bar, and all the services you might be able to access as autonomous economic agents, the network can act as a dating agency to place all the right ones together at the right time, so that if you've turned up with a book by yourself in the evening at a hotel far, far away from home, then maybe you're going to have a glass of wine. And if you turn up with your mates and there's a football match on, then maybe you'll get a completely different set of options. But the idea that you can present people precisely what they're likely to want with far, far better accuracy than before, and continuously learn and adapt, even though you may not have seen some of these situations before, is a very cool way of reorganizing user experiences. It also means that that whole annoyance of upselling, where you go, oh, no, I don't want that, no, I don't want that either. A lot of that annoyance disappears, because when you understand the context, when you suggest to somebody, oh, you probably want a pack of crisps as well, it's like, do you know what? I do want a packet of crisps. And the idea that you can get that stuff right more accurately with a network like Fetch moving everything around underneath was a really interesting application that we hadn't considered.
Okay, that raises 2 questions in my mind. The first one, just with the roadmap. When are you likely to have a mainnet?
Sorry, I got distracted.
That's okay.
My apologies. I know. But that meant I completely failed to answer the question. Mainnet, the second half of next year.
Okay.
So we've got everything, all the key stuff up and running. The private test net will be becoming gradually less private over the next few months. So more and more people will be able to connect to it. We've got, we're working with various commercial partnerships, looking at the applications and academic partnerships as well, looking at different things that we can put in the Fetch network, looking at the different kind of applications that we can build out of it that we haven't considered, and seeing how they interact with each other. And giving a broader audience access to this network. So in the coming months, for example, we've got a community developer site that's coming up, which will allow people to get access to bits and pieces, build agents, deploy them on the network, talk to each other, share their knowledge, and actually get things done. Because if there's one thing that we know, is that people have imaginations, and if you give them a platform on which they can build things, they will build things. And you don't know what people are going to build until you provide the environment for that. In the same way that when Apple popped out with the App Store, we saw entire new classes of application appear almost overnight, as individuals suddenly had the power to take what was in their mind and deploy it, just like that. And with something like Fetch and these decentralized networks, where the power goes from the center to the outsides again, suddenly these opportunities exist again. You might be sitting around, looking around your living room and saying, I could put an agent on that, I could put an agent on that, and then you can. And then you put it on the network and see what happens. Now, I find that fascinating. I've now taken to sort of walking around and I see things now as populations of agents. I see a car as a population of agents, the vehicle itself plus all these other things. Now, that's information. And that information provides an interesting view of the world, which is different from trying to just look at it through a camera and interpret everything in the space, because everything knows what it is.
That is a crazy thought. Absolutely crazy. How do you encourage adoption then? So let's say you have the mainnet up and running, but now you have to get people on board. What are you going to carry out at that point?
Well, this is the grand bootstrapping problem. And of course, we all know this from computer games, right? Nobody wants to be the first person.
Yeah, you already want to play if everyone else is playing.
Precisely, but you've got to start that process somehow. And in the case of computer games, you make people not feel alone. You have non-player characters. You have all these other things running around the world. And you try and release it in a way that groups of people are encouraged to be in certain places. And this is very important. It's the same way that Facebook unrolled. You
have to build the network.
Build the network in one place. To the point where it's essential for people if they want to be connected. And then you move to another place and you repeat.
Absolutely.
You don't get a small spread everywhere, because in the end that doesn't work. Now we understand this. And we know and that's one of the reasons why we have to pick these particular areas like transportation and mobility, energy, healthcare, logistics and supply chains. We have to work in these areas with a small number of partners in order to get useful applications up, because once Fetch is up and running and connecting all these things together, as I talk about infrastructure projects and any large building with equipment in it where you lose things, suddenly the equipment can't get lost anymore because it knows what it is. And it's the thing that says over here. And that's a wonderful thing, because it wants to be used. And the fact that it's sitting in a corner is not where it's meant to be. It can now come up and say that. So getting success in building useful applications in these individual areas first is very, very important. But also doing things like attaching agents to the sensors in your phone.
So is the focus on what is going to be in business to begin with? A lot of the things you mentioned there are more focused business than retail.
But you think you know how it's going to be applied, then you get surprised, right? Which is why we've got this thing called the network participation application, which you can put on your mobile device. You can create agents that represent the sensors and other things on your device, and then press a button and launch an agent.
And what's the incentive to do that?
Because that value, and any value that's generated from that, comes to you.
So I could monetize my data?
Yes, you could. And you get to see, you could build 10 or 20 individual agents with different combinations of sensors. You can see which ones succeed and which ones don't, and also under which circumstances. And then everything that they collect can come to you. They're your agents.
This kind of goes...
And that's a drag and drop thing, by the way. So you press add agent, you take the sensors you want, you drag them in, press a button, you've launched an agent. And you require no programming experience whatsoever in order to be able to do that.
And the key difference between this and many other projects is that you could have thousands of different things, so your data could be coming from thousands of different areas, not just here's what I do on Facebook. It's, as you say, it's the sensors in my phone, it's the accelerometer, it's picking up details which other projects wouldn't be able to.
Whether you're using
that still raises the question of, I would have to go through the initial process of deciding all of these things. Do you know what I mean? If there's thousands, there's 1,000 different parameters, I would have to turn on or off 1,000 different parameters.
Well, no, because actually with a lot of these things, this is 3 drags and a press. So if you want to create an agent that represents, for example, whether you're using the device or not, that comes back to one of the things we said earlier about if people put their phone away, maybe the weather has changed, particularly if they do it collectively
together.
Then that's dragging one thing in, pressing a button, you've launched an agent. I mean, that was that. If you want to give away potential information about your approximate movement status and location, so that people can track whether you're stuck in a queue or whatever, then again, it's 2 things dragged in, press a button, configure the accuracy, and away you go. And this is very straightforward, and we know it needs to be.
Yes, you've got to make the interface simple.
It's got to be trivially easy. And the same applies with the SDK. If we're expecting developers and people to turn their stuff into agents, then we have to make it very easy for them to do so.
Okay, so my question pertains to data. When I first came across the combination of blockchain and data, those types of projects, my first thought was, this is a great idea, but at the end of the day, I'm not willing to sell all my data. I might sell 60%, let's say. I can monetize it, but if there's 40% that I'm not willing to sell, then there's incentive for a company to still collect that data on me and monetize it by selling it to a company.
They'd have to pay for it though if it was done through something like Fetch.
Okay, I'll come back to that. Let me just finish. So then I came across a project called Enigma. And I don't know if you're familiar with it. They introduced something called private smart contracts. I don't know if it's functional yet, but the idea is that companies could use my data without actually seeing it. So they could run computations on it without being able to visibly see it.
Yes.
And that for me changed everything. Because now I'm willing to sell 100% of my data because I know no one can see it. And suddenly there's no incentive for a data company. So the key thing here is the data going to be public? I might be willing to sell data on my phone, but not if people can see it.
Yeah, no, they can't. Right. Okay. The key thing to get here is that when you create an agent and attach it to data, what's on the actual network is your agent representing that data. The data itself is not there.
Okay.
And when an agent is introduced to an agent in a form of value exchange, that is encrypted.
Okay.
So and that's super important. The kind of things that you're talking about there, the idea that computation can be done without you releasing the information also is something that's important to us. There's some very, very, very interesting technologies going along this subject that is really important in this space. Been able to, for example, with so much proofs, been able to prove that something is true without having to give away all the information. Like in a lot of cases, people need to know that you have a job, not specifically what it is. That you earn more than X, not specifically what your salary is. That you're old enough to have a drink, not what your date of birth is. But we leak way more information than we should. And there are technologies, very exciting ones, that are there to be able to do that. Like, for example, being able to perform computation on data without knowing what that data is. You know, that kind of stuff is very interesting. And this opens up other applications, of course, because you could do collaborative models then. So you might have company A and company B, who might be car companies. They have an awfully large amount of data that allows them to predict when their cars are likely to break down. Now, company A and company B would love to be able to pool their data, but they're not going to give it to each other because, well, you know,
because they can see it.
Exactly. Now, if they could both contribute to one model without giving away their proprietary data,
that's where a lot of their value is.
Then they both benefit from having that, but neither of them have to give away any of their proprietary information. Then it becomes interesting. You've got collaborative predictive models and all sorts of other things that can be done as a result of that. But key to this from a Fetch perspective is your agents are representatives of data, not the actual data themselves. And they are digital entities in their own right. If you knock them all out every week and create new ones, then they're entirely new identities on the network. So there are all sorts of ways in which you can ensure that the information that is important to you stays with you and under your control. And then these entities go out there representing that. Any transaction is effectively under your control anyway. The data isn't revealed on the network, which is, of course, super important. And anybody who wants to collect that, if they were data mining individuals in an area, they'd have to pay for it. Now that works well, for example, if you're just happen to be walking around the station and a little bit of information is bought off individual agents that represent your staff, which you receive value in order to build something bigger and grander. Because in the end, you're generating value just by walking around, going about your day-to-day life. You're not having to worry about it, it's just happening. But you're always in control. Your data remains with you and with nobody else.
That is fantastic to hear. For me, that's the key. If the data becomes public, the whole idea of monetizing your own data, I quite frankly don't think it's going to catch up.
We won't store that kind of information, and we don't want it.
Exactly. So let's talk about the token use and token velocity now. These are unbelievably important topics, and I kind of bore everyone that watches videos because I go on about it so much. But there's so many projects I see which are brilliant, and I think they're going to take off and they're going to be successful. And yet the token isn't fundamentally useful, so no value is going to accrue in the market.
Yes.
Or even still, it might be fundamentally useful, but there's no incentive to hold tokens. So you come across the issue of token velocity, where tokens are flowing through the system so fast that tokens once again don't accrue any value.
But velocity in an economy is a really tough one to get right.
Yeah, it's all kind of hypothetical at this point. I think we need to see it play out, but I don't know. I'm personally of the opinion that too high a token velocity is going to be quite a major problem with many of the crypto projects out there. So how have you guys addressed it? What's the token use, and how have you addressed the issue of token velocity?
Token velocity is an economic subject in its own right, in all kinds of economies, because you do want that value to be used. You don't want it just to be hanging around and not doing anything. You want it to be turning over in the economy.
But there's a speed which is
that's
good
right.
on the speed,
Absolutely, and there are papers and books about this which make fascinating reading. By the sounds of it, you've
some of them, probably not enough.
But yes. And that's also a problem, right? Because you wouldn't buy a coffee with an Apple share.
No.
So there are certain reasons why you wouldn't do that, and in non-complicated transactions where you've got the risk that the values might change substantially during the transaction itself, or that when you finished it, 3 months down the line, everything has changed so dramatically that it doesn't make any sense anymore. These are big problems. And in a network like Fetch, these are important problems. Now, the actual utility value of the token itself is even more important in a network like Fetch, because it's not just humans to machines that are trading. This isn't just a value exchange method, so you or I could perform a transaction. It's not like you are buying a piece of data or you're sending me some tokens. We've got the whole machine-to-machine economy to worry about with Fetch. It's these digital entities, they're transacting at an incredibly high rate, independently of any human intervention, sending these tiny little transactions all over the place while they combine and move information around and build further predictions and further value out of it. And of course we need to build a token into this system, because you need to be, for integrity of the network, and for a bunch of other reasons, you need to be in control of the method of value exchange. Otherwise, it just doesn't work.
So the integrity network, that relates to staking, am I correct?
It's a combination. We've built something which is a really interesting combination of a lot of these things, because again, in the end, we had a unique problem set we had to address. When you've got potentially so many billions of agents performing these transactions at such a rate, and they might be very low value transactions as well. You're not going to spend much more than 100% to buy the temperature just up the road, if that. So if the cost of doing that transaction exceeds 100%, then
it's not realistic.
That's not going to happen. But on the other hand, if people are processing transactions and packaging them, there's processing power involved in doing that. So you need it to be low cost, but not free.
Otherwise you encounter speculations as well.
Precisely, and you need to have feedback mechanisms in the economy in place that ensure that those costs don't go up. Now, of course, with Fetch, actually one of the reasons why, and one of the primary incentives for running a node on the network, is providing services to agents, rather than say, a proof-of-work system mining away. And other mechanisms. Actually, over a period of time, as the knowledge on the network builds, you, as a node, are selling these advanced services and predictions and trust information to individual agents and connecting them together in order to allow them to get things done. Now, curiously, that's actually also an incentive for further decentralization, because any given node on the network can only support so many agents. There's all sorts of reasons why that's the case: number of network connections, resources on an individual computer, and such, all sorts of things. But then that means that eventually you have to set up additional nodes in order to support an increasing population of agents. And we've been able to do some very neat things with the underlying infrastructure of the network as well, to allow that to reorganize itself in interesting ways, to present other views to the individual agents as well, so that they can explore the network on more dimensions. Because unlike the real world, where we all have to see the same space, the digital world has no such restrictions. Every agent can see something completely different. That agent right in front may not be in front, may be important. And that's a combination of things like semantic views, content-based views, and geographic views, and all sorts of other things. So fundamentally, the token is moving around all the time because it's been transacted by all these individual agents.
So that's one of the use cases. I want to try and narrow this down as much as possible. I know you kind of covered it there, but I want for the viewers to make it nice and easy, if we can, like a 1, 2, 3 sort of thing. So one of them you've covered, interacting between the agents. That's the medium of exchange element.
Yes, and that is the primary use that is going
Yeah.
on, which is it is the unit of value exchange between agents.
Okay.
But it's also the way in which nodes on the network are given value for the services that they deliver.
And I also read that staking was one of the parts to it.
There is a combination. It's a bit of a weird combination. It takes a little bit from proof of stake, takes a little bit from some other aspects of proof of work in order to build something that is unique. But yes, there is a part of that.
Who will be staking in that then?
Well, in that case, it's the individual users that are part of reaching consensus. Now, the consensus mechanism is something we've got very interesting and hopefully really accessible paper coming out, banging that
Useful
one
proof
down.
of work.
Indeed,
We're not going to
banging
go
that
too
one
much detail
down in more detail in the next month or so. So hopefully we'll have that out real soon, along with a demo that shows how all of this works. But the idea has always been right from the outset that we know from bitter experience over the last 10 to 20 years that the amount of computing power you need in order to restructure a world and provide this trust information, these predictions, is extraordinary. And to be able to use the computing power of the network to do that, then that gives you something really special, because that solves the whole client-server thing, where you have to have a really big fat computer here, and then lots of little computers have to share that resource, which just doesn't scale. So that's why we needed to innovate in that space in order to be able to create that. We've also had, just to reverse back into token velocity, and this is an area that's been very dear to us, and we, as part of our team, we also have economists involved in making sure that we do all the modelling for all of this and seeing how all this works, but also to explore other innovations and other things in this space that can help with that. And that's something else that we hope to be able to talk a lot more about in the coming months too.
Okay, so one of the critics of medium exchange type tokens has been token velocity.
Yes.
As I say, I know at this point it's all very speculative. Until we, 5 years, 10 years down the line, we don't really know. But how is this not potentially an issue for this project then? How would token velocity not be very high, which could devalue tokens?
Token velocity, getting that exactly right is a really complicated thing, and I've seen some spreadsheets that give me nightmares at night with the modelling behind them that show how all of that works. But it is possible to put in place the right feedback loops, because in the end, you have the same problem in real economies, with real money all the time. And particularly in small communities where you've got very little velocity, larger ones where you've got potentially an enormous amount of velocity going on. I mean, this stuff is hard to get right. But there are all sorts of levers that can get pulled in order to control this. And there's all sorts of aspects relating to interest rates and other bits and pieces that are levers that people pull in order to control how all of these things work. Now, one of the problems with decentralization is the way in which you pull those levers changes, right? Because you have no central banking authority to twiddle here and twiddle there. And that creates difficulties, particularly when it interfaces to other aspects of the economy. And we've seen a lot of that with what happened a year ago when all the cryptocurrencies were going up. And of course, we were seeing something very different occurring at the moment, right? And in some cases, you could see how when that tied into other financial vehicles outside of the crypto space, where that might have had an influence, an undue influence. And you're right, this is a young space, and we are all learning. And that's why we have to do it in conjunction with all of this expertise and enable the possibility of doing different things with it in the future.
So I'm going to push you here. And I kind of want to know what the exact levers are then. What is going to happen to reduce token velocity?
And the precise levers are something that I'm not able to talk about just yet, but will be able to talk about very soon.
Okay.
Because that relates to the possibility of doing very interesting things with the underlying token in order to ensure that for, like the example of not using an Apple share to buy a coffee, that you have the higher velocity aspect of it and the lower velocity aspect of it, and you have a degree of separation so that those levers or those things can be pulled independently from the network itself.
Okay, so
It's a very interesting topic.
yes, it is. Yeah, it's something I'm fascinated by. But I guess we'll just have to probably come back to this then. Not today, obviously. I'll have to just come back to this to update everyone, because it's something I always talk about on the channel. And to be honest with you, I've been quite critical of medium exchange tokens, because I think they will tend to encounter this issue. But as I say, I can't assess if there are things which are going to change.
And they are an essential.
I can't assess it. But now we're going to wrap up with our final two questions, which next is the most interesting, probably the easiest question. Why should people invest into Fetch?
Why should people? Well, we obviously haven't talked about token sales at this point.
Should we try to cover the token sale?
No, yes. This was the easy question, you say.
No, I mean,
the reason why people the reason why people should get involved in Fetch and all aspects, particularly in the development thing, is that we are building something new, and that we're enabling a new class of applications by bringing all of the individual components in life to life, and giving them the authority to get things done. And we live in an increasingly complex world that is very hard to make sense of sometimes, and it does feel like the kind of problems that we solve are like, as I'm fond of saying, pushing hot water uphill. It shouldn't be that way. Fetch changes all of that. It's a new platform for doing this stuff. You're surrounded in dumb things. Dumb data, dumb hardware, dumb services, and dumb infrastructure. It's dumb because it hasn't got any ability to know about what it is, what it does, or how to do anything better. Well, Fetch changes that. And that's why it's different, and that's why people should get involved, because they can, and we're going to make it very easy for them.
Just a final question then. If you'd like to leave the audience with a message, it could be about cryptocurrencies, blockchain, life in general, what would you like to say?
This stuff doesn't exist in isolation. It's very easy to look at blockchain and say, oh look, blockchain. But where it gets interesting is where it is a component part of something grander. This is what we're seeing more of these days. This is very exciting. I liken this space to what was happening on the World Wide Web in the mid-90s. We all know that it is going to fundamentally change the way we live our lives. We can't quite put our fingers on all the details of how, but there's a lot of people doing some extraordinarily exciting things in this space. They're combining blockchain with AI, they're combining blockchain with other things, and they're building new architectures, new platforms upon which new kinds of things can be done. I think that's very, very exciting. Fetch is one of those things, and I think that combining this technology together is going to be an extraordinarily exciting thing. It's a great space to be in, it's a great pleasure to be in it, and I think we're doing something very different with Fetch.
Okay, that's a fantastic message. Thank you so much for your time.
It's my pleasure, thank you.